Hello all, myself Sambasiva Rao, working as Assistant Professor in the Department of Civil Engineering at VNR VJET. I welcome you all to the lecture series on highway geometric design. As a part of the series, the topic of discussion for today will be superelevation. So if you look into the definition of superelevation, so the superelevation is nothing but the transverse slope provided to a roadway by raising the outer edge of the pavement above the inner edge on a horizontal curve. In order to reduce, already we have discussed this centrifugal force effect in the horizontal curves in the previous presentation. So in which we have seen that there is centrifugal force P which is acting horizontally outward direction. So that is what the effect of centrifugal force. So as a result of that, the vehicle traveling or the traversing on the horizontal curve has a tendency of overturning or the tendency of sliding. So we have to counteract the overturning and sliding by introducing some portion, some component. That component over here is nothing but superelevation. So that is been mentioned over here in order to reduce the effect of centrifugal force and improve the vehicle stability while moving on the horizontal curve. So this is what the superelevation. You can just remember that the rise of the outer edge. So if I take over here, so this is my outer edge. So because the centrifugal force is acting on this direction, so this is my inner edge. So previously it is nothing but this, both of them will be at the same level. So this is nothing but my inner edge and this is nothing but my outer edge. So the rise of the outer edge of the road when compared to that of inner edge. So this is nothing but superelevation. So that is being mentioned over here. The same thing has been over here. So this is nothing but inner edge and this is the outer edge. But whereas if you do that, this superelevation is being provided by rotating the pavement about the inner edge. So that is why your center line is also being shifted by some value. Okay, so I forgot to mention the camber definition in the other way. So previously we have been looking at the camber, which is nothing but this. That is nothing but the slope provided in the transverse direction to the road. That is nothing but a camber to drain off the rainwater. But that is also called as the rise of the central portion. So this is the inner edge and this is the outer edge. So the rise of the central portion of the road with respect to outer edges, with respect to edges. The rise of the central portion of the road, you are raising the central portion of the road when compared to that both the edges. So this is said to be the camber and this is nothing but the superelevation. Anyhow, the camber is nothing but the slope provided perpendicular to the length of the road to drain off the rainwater. So that is a definition which we have seen while discussing the camber in the previous factors controlling geometric design. But in this condition, so we have to distinguish between camber and superelevation. So that is nothing but this is the camber rising the central portion with respect to the edges, and this is nothing but the rising the outer edge of the road with respect to the inner edge. So that is what the superelevation. And this is what the vehicle which is traveling on a horizontal curve when being provided with superelevation. So far we didn't see what is meant by superelevation, the horizontal curve. We have seen only the centrifugal force which is acting on the horizontal direction outwards. Now we are providing some component to reduce the effect. So in order to reduce the centrifugal force acting on the horizontal curve, we are introducing some component on the road. That component is said to be the superelevation. So this is nothing but the rising of the outer edge. So the rise of the outer edge, so this is my outer edge. I have raised this outer edge by value E and this is my inner edge. So in order to compensate the centrifugal force. Now irrespective of the orientation of the vehicle, so my vehicle is nothing but inclined on this wedge portion or the raised portion of the road. So my centrifugal force still acting on the outward direction horizontally. So that is what you have to remember. And this is the weight of the vehicle which is acting vertically downwards. So the two forces which are acting here will not change over here. So the directions also, this is horizontally outwards and this is vertically downwards. So now we will try to resolve these forces along the plane and perpendicular to the plane. So this is my plane of road or this portion, this plane. Now I try to resolve the forces which are present over here. So that is nothing but the centrifugal force as well as the weight of the vehicle over here. So we'll just see what is the small things over here. So this is nothing but the theta, that is nothing but the angle of superelevation. So if this is theta and this is 90 degrees over here, so this will be 90 minus theta. So this is theta over here. So if we extend this, so this is a triangle formed over here. So this is a right angle over here. So this will be 90 minus theta. and this is again 90 over here. Basically here it is 90, so therefore theta 90 minus theta, and this is 90 minus theta, so therefore this value has become theta. And I'm just drawing a line which is parallel to the plane over here. So this and this are both perpendicular, so this is theta, this is 90 minus theta, and again this and this dotted line is again perpendicular, so therefore this is 90 minus theta, so this will be theta. So that is what the resolution of the forces. Okay, now once you resolve these forces, so this is the weight component and it is separated and it is having an angle theta. So therefore this component of weight will be W cos theta. Okay, and the component of the weight which is acting along this plane in this direction is nothing but W sin theta. And this is the centrifugal force acting over here, and this is theta separated by theta, so therefore this will be P cos theta, and P is acting over here, so therefore the weight which is acting in this perpendicular to the plane of road is nothing but P sin theta. So these are the different forces which are acting over here, and as you know that the vehicle is being moving, because of the centrifugal force, the vehicle is trying to slide in the outward direction, so therefore there will be some frictional forces acting over here. So let this be B and let this be A. Okay, so therefore you have RA and RB over here. So this is nothing but RA and this is nothing but RB. So therefore you are going to have some frictional force generated over here, FB over here and FA over here. So these are the different forces which are acting on the vehicle. So the same thing finally established figure is shown over here. So this is nothing but theta and this is nothing but theta. So this is P, so therefore it will be P cos theta, and this will be P sin theta. So it is being shown up to here, and this is again theta and this is W, and therefore along the perpendicular to the plane it will be W cos theta, and this will be along the plane in the backward direction, it is nothing but W sin theta. Now we have to go for again resolving the forces, writing the equations of equilibrium along the plane and perpendicular to the plane. Now I'm going to write the equation along the plane of road. Forces sigma of x is equal to 0. Therefore, what are the forces we are acting, which are acting over here is nothing but P cos theta is acting in this direction, and W sin theta is going to acting over here, and therefore the other forces which are acting in the opposite direction is nothing but FA plus FB. So therefore you have P cos theta minus, which are acting in the opposite direction, W sin theta minus FA plus minus FA minus FB. So I'm writing in the bracket FA plus FB. So this is what present over here. Okay, so therefore this is equivalent to 0, of course. So therefore P cos theta minus W sin theta, I am shifting this over side, so W sin theta plus FA plus FB is equal to 0. Okay, now I'll write the equations perpendicular to the plane of road, So that will be perpendicular to the plane of the road. So we are having the forces RA plus RB, which is nothing but sigma Fi is equal to 0. So the forces which are acting on the downwards is nothing but P sin theta plus W cos theta is equal to 0. So these are forces which are acting downwards, and the forces which are acting on the upwards are nothing but RA and RB. Okay, so therefore minus R and RB are acting down upwards, so there will be in the negative direction, so I'm taking minus common. RA plus RB is equal to 0. So therefore from this you can write it as P sin theta plus W cos theta is equal to RA plus RB. This is equation 2. Now you try to this equation, which is 1 over here, so I'll still simplify this. P cos theta is equal to W sin theta plus FA is nothing but frictional force which is acting over here. So we know the formula for frictional force, which is nothing but F is equal to coefficient of friction, I'll take it as FL over here. So already we have seen this coefficient of friction into normal reaction, that is nothing but R reaction. So therefore if it is FA, I can write it as FL, lateral coefficient of friction, into RA, plus this will be again lateral coefficient of friction FL into RB. Okay, so this again, if we simplify this, P cos theta is equal to W sin theta plus FL if I take common. So this is RA plus RB. So this is equation 1. And now we have the equation 2 over here. So we have the equation 1, which is nothing but P cos theta is equal to, I'll try to solve in the next slide. P cos theta is equal to W sin theta. Therefore, P cos theta is equal to W sin theta plus, it is FL into RA plus RB plus RB. So that is the equation 1. And similarly, we have the equation 2, which is nothing but P sin theta plus W cos theta. P sin theta plus W cos theta is equal to RA plus RB. So this is the equation 2. Now I have to substitute the equation 2 over here in equation 1 such that I can get the value of RA plus RB over here. Therefore, this is equal to P cos theta is equal to W sin theta plus FL into, which is nothing but P sin theta plus W cos theta. So this is the, after substituting RA plus RB, we have got this equation. Now we try to divide this entire equation by W cos theta for simplification in order to attain the, arrive the value of superelevation. So divide this equation with W cos theta, entire equation with W cos theta. So if I divide over here, so P by, I am dividing with the W cos theta, so therefore W, and cos theta gets cancelled, so we are left out with P by W, and here W by W gets cancelled, so sin theta by cos theta, which is nothing but tan theta, plus FL, first term will be P by W, so therefore P by W, and again sin theta by cos theta, so therefore it will be tan theta multiplied by FL, so this will be multiplied by FL, plus W gets cancelled, cos theta gets cancelled, but we are left out with single term, which is nothing but FL. So this is what over here. Now I'll try to rearrange the terms which are having P by W over here. So P by W, if I take common, 1 minus tan theta into FL is equal to, so therefore if the terms go on the other side, so we are left out with FL plus tan theta. Okay, so when theta is very small, when theta is very small, or sin theta is equal to tan theta is equal to theta. So that is what superelevation. We can represent this as also a small e for simplicity purpose. So therefore this equation, and you all know that when theta is very small, tan theta is very small. So therefore this value is very small. So, and again FL is going to be lateral coefficient of friction, which is also very less. So this entire value will become 0. So therefore P by W into 1 minus 0. So this will be simply 1 is equal to FL plus tan theta is nothing but sin theta is equal to theta, and again that theta is equal to E. So therefore we can substitute this as simply P by W is equal to FL plus E. So therefore this is a very important equation which is having the superelevation. So therefore E plus FL is equal to P by W. Very important. P by W is nothing but centrifugal ratio. P by W is nothing but centrifugal ratio, which means nothing but the centrifugal force is being compensated by two terms present on the road, which is nothing but, one is nothing but superelevation. So that is what the main purpose of introducing the superelevation, and at the same time you also have another parameter. You can take the another advantage of the road, which is nothing but the lateral coefficient of friction in reducing the impact of centrifugal forces. Either you can provide any of them or you can provide only one of them, such that you can reduce the impact of centrifugal force and keep the vehicle stable while moving or traversing on the horizontal curve. Okay, so this is a finalized equation where we have this E plus FL. So to be precise, this is lateral coefficient of friction. E plus FL is equal to V square by GR. Again, this V is nothing but meters per second. Okay, so the speed of the vehicle in meters per second. So small v stands for, and E is nothing but rate of superelevation, that is nothing but tan theta, and FL is equal to lateral coefficient of friction, which is nothing but the 0.15 standard value, and R is nothing but radius of the horizontal curve in meters, and G is nothing but acceleration due to gravity, 9.8 meters per second square. Okay, so this, if we convert this into capital V, okay, we already know the relation between small v and capital V. Small v in meters per second is equal to capital V divided by 3.6, or this will be 0.278 capital V, or simply you can substitute the value as small v is equal to capital V by 3.6 whole square divided by GR. So if you substitute that, you'll get a standard equation E plus F is equal to V square by 127R. So there are instances where the direct E plus F is equal to given in directly capital V square in some of the competitive examination. So you can remember this value also. You need not to waste your time by doing this. So E plus FL is equal to V square by GR in terms of capital V. Sorry, in terms of small v it is V square by GR. In terms of capital V it is nothing but V square divided by 127R. Now in this condition you can see that this part component is nothing but regarding the centrifugal force which is acting on the vehicle. same, this and this is nothing but the component of the centrifugal force. Now this is being compensated by any of these two. That is nothing but either you can compensate the effect of centrifugal force by introducing superelevation, or you also can compensate the impact of centrifugal force by compensating FL, by introducing FL. So you can take the advantage of both of them, or you can take any one of them. So if the coefficient of friction is neglected or assumed as 0, so that is nothing but you are taking the FL is equal to 0. Okay, then that kind of superelevation is nothing but equilibrium superelevation. Very, very important. So what is the term equilibrium superelevation means? When there is no effect of centrifugal force, when there is no effect of lateral coefficient of friction, and the entire centrifugal force is being balanced by only superelevation, such a kind of superelevation is nothing but equilibrium superelevation. It means nothing but you are trying to balance the pressure on the inner wheel and the outer wheel being equal. So such a kind of superelevation is nothing but equilibrium superelevation. So here you have to introduce the term E equilibrium. Very, very important. So this is nothing but E equilibrium. So that is nothing but when FL is equal to 0, this condition. At the same time, you can take the only advantage of lateral coefficient of friction when you don't have to provide superelevation. When you don't have the chances of introducing superelevation, you can compensate the entire effect of centrifugal force by introducing only lateral coefficient of friction, wherein which you will get the value of E is equal to 0. So therefore E plus FL. So as E is equal to 0, F is equal to V square by GR in terms of small v, or in terms of capital V, it is nothing but V square divided by 127 R. So from that you can calculate what is the value of capital V if required. Okay, so this is how you attain the superelevation basically. So I've told you that initial in the previous presentations regarding the horizontal curves. So there is a straight portion followed by a transition curve, and there is a central curve. So I have divided this into 3 zones in the previous presentation. So this is zone 3 and zone 2 over here, zone 3 here. So this is nothing but transition curve, and this is nothing but a circular curve. So this is nothing but circular curve, this is nothing but straight path. Okay, straight path. So therefore here initially you are having this has to be camber. So that is nothing but at the edge of this portion. Okay, so till this portion, this is the straight path. So this portion is nothing but zone 1, and this is the intersection point. So this is section AA. So this is section AA. You started slowly till this you are having camber only, and after that you are slowly introducing your superelevation. That is nothing but this is outer edge. You have to remember here, instead of providing outer edge on the right side, whereas in the previous slides, okay, I am providing the outer edge on the left side, and this is nothing but inner edge. So now again the definition of superelevation is nothing but the rise of the outer edge with respect to the inner edge. So that is nothing but superelevation. So therefore, so you can see that the superelevation is not suddenly provided at the junction of the circular curve. It is nothing but you are not introducing the high amount of superelevation, that is nothing but full amount of superelevation just at the instance of a central curve. So we are introducing slowly, we are introducing this value 0 to capital E. So that is going to happen in transition curve. So you are going to introduce slowly from 0 to the capital E value. Okay, and then you are going to maintain the constant value of E up to the complete length of the central portion of the circular curve. And again there, when you enter transition curve, again you reduce the superelevation from E to some particular 0 value, and then from there itself again you are going to have the normal camber. So this is one thing which you have to remember. So far the discussion we made, or the derivation we have done, is only the superelevation regarding to the central portion of the circular curve. That is nothing but the full amount of superelevation. So but generally it is provided like this. So there will be attenuation of superelevation gradually from straight path to the central portion of the circular curve by providing some rate of superelevation. So this is a full elevated superelevated section. So this is nothing but we have a camber over here, wherein which we are having the central portion raised with respect to the edges, and by the time you reach somewhere in the middle, so you are bringing the outer edge to the level of the camber. So this is nothing but outer edge, outer lane is flat superelevated transition, and after that still you are going to introduce the full amount of superelevation in the central portion of the circular curve. And this is very, very important for so far we have seen the discussions regarding the superelevation, we have seen the derivation for that, and basically you are not required to calculate. Sometimes you are not asked to calculate the superelevation. If the values are given, it is very easy to calculate the superelevation value, but if it is designing the superelevation is a different story. Okay, so that is what here it has been mentioned over here. The steps for design of superelevation is nothing but Here very important, the superelevation is only done for 75% of the design speed. It is nothing but you are not designing your superelevation for 100% design speed, because in Indian conditions we are going to have heterogeneous traffic, which is nothing but different vehicles traveling at a different speed. So we don't want to design our superelevation to 100% design speed, which will be conservative, or it may require huge amount of superelevation to be provided at the outer edge. So for which we are going to design superelevation only for 75% of the speed. Here students have to be very careful while you are taking the superelevation, design superelevation, E-design. I'll call this term as E-design. When we are taking 75% speed, generally people get carried away by writing 0.75 V, only square will be putting all to V. But that is not the case. We have to provide, instead of speed we have taken 0.75 V. So therefore this V square will become 0.75 V whole square divided by GR. I repeat again. So instead of small v, we have to take 0.75 V and that numerator whole square. So instead of speed V, we are taking 75% of the speed. So therefore, then this equation is going to be reduced. E design is equal to, again, if you substitute the conversion, of small v to capital V, this value will turn up as V square divided by 225 R. So this is again in kilometers per hour. Previously we have seen the superelevation E plus F is equal to V square by GR. In terms of capital V, it is nothing but V square divided by 127 R. But here design superelevation is when you take 75% of the design speed. So then E design is equal to capital V square divided by 225 R. Okay, so first thing you have to calculate the design superelevation. This is an you are assuming some design superelevation and you are calculating the value of design superelevation. So then you see that so the superelevation for 75% of design speed is calculated neglecting the friction. This is also very important. So you have to eliminate the effect of lateral coefficient of friction and you have to assume that there is only superelevation present over here, and you have to check the limiting values of superelevation. After calculation of the superelevation, you check that whether the superelevation what you have calculated or what you have arrived is less than the maximum value of the superelevation. Then your problem ends there itself. So whatever you are getting the superelevation value, so that is superelevation you are going to provide at that respective location. So that is the end of the problem. But if not, so if your superelevation in plain areas, maximum superelevation is nothing but 7%. So in a plain terrain, if the superelevation has been crossed to 7%, then you have to go with the second step, where we have to take that E plus FL is equal to V square by GR. Here we need not to take again V design or 75% as a speed. Here we have to take the full speed. So therefore E plus FL is equal to V square by GR, and you already calculated the value of calculated superelevation E design. So if E design is carrying more than E maximum, then you restrict the value of E design to E maximum. So this value will become E design. This is the second case when you get the E design value higher than that of E maximum. So you take the E design value, whatever it is, more than 7% means 9 or 10%. You substitute the value and you check for FL. Already you know this value, V square by GR. You'll calculate this value and you'll see that value of FL. So that is what it has been mentioned over here. So therefore FL is equal to V square by GR minus 0.07 only in this particular case, when the superelevation and maximum superelevation is 0.07. But in other mountainous and steep terrains you can have 10%. So respectively the value is going to change over here. So if the value of FL thus calculated is less than 0.15, the superelevation 0.07, because we have restricted the design superelevation to maximum. So this design is nothing but this maximum design superelevation will be taken as higher value, and then we are restricting that. So if FL is less than 0.15, so then your problem ends there. That is the second case. The first case, you are calculating the design superelevation where by taking only 75% of the speed. If that value is higher than that of maximum, then you are restricting the design superelevation to the maximum value. Okay, you are getting 10, 15, you are restricting it to 7% or whatever it is, a higher value. Plus you are checking for the lateral coefficient of friction, taking the full speed, not 75% of speed. Then if the FL value is less than 0.15, then again the problem ends over there. But let us assume that still in this case FL is greater than 0.15, then you have to restrict the values of both FL and E design. So that is why you have to take the maximum value of superelevation. So that is nothing but E design or E maximum plus FL maximum. So which is nothing but lateral coefficient of friction. There will be giving the maximum value, or else you have to assume some particular value. So you have to fix these both the values and you have to take this value as 0.22. in this particular case, as we have taken the maximum super elevation as 7%, so this value has turned out to be 0.22. And here there is a new term introduced over here, so that is nothing but VA. Instead of capital V, we are trying to reduce the speed of the vehicle for that particular portion, and that particular speed is nothing but allowable speed. So the formula remains constant, E plus FL is equal to V square by GR, as E and FL has been reached the maximum values. So we are restricting that maximum values, and we are trying to revise the speed that can be allowed on that particular section of the road. So that kind of speed is nothing but allowable speed. So therefore 0.22 is equal to VA square by GR. So similarly from that you can get the value of VA, that is nothing but allowable speed on that particular section of the road. So you'll get in meters per second, and of course you can convert that into kilometers per hour by multiplying with 3.6. So these steps are very important. I once again repeat the steps that have been carried so far in designing the super elevation. First one is nothing but design, first step, E design. So I'll write the names also differently. E design is equal to, you have to take 75% of the speed, 0.75 V whole square divided by GR. So if E design is less than E maximum value what has been provided, so then the problem ends over there. So if E design is greater than E maximum, so then in the second step you have to take, instead of E design you have to take E maximum. You have to restrict, because if E design is higher than E maximum, so then you shouldn't take the design value. You have to take the E maximum value plus lateral coefficient of friction is equal to, you have to take the 100% speed, design speed instead of 0.75%. Then you have to check for FL. If FL is less than 0.15, this problem ends over here. So with that particular value of maximum super elevation and this value of lateral coefficient of friction, whatever it is less than 0.15, you are going to incorporate the same values, and the design ends over here. So if that is not the case, if FL is going to be increased by 0.15, then you have to restrict both of them. So therefore E maximum, because already E has been exceeded its maximum value, and FL also maximum. So I'll write it as FL maximum is equal to, you have to reduce the speed VA square, that is nothing but allowable speed, is equal to GR. So therefore whatever the code recommends the maximum value of super elevation based on the type of the terrain, you have to incorporate that value, and FL maximum, it will be remaining constant respect of the type of the terrain. So you take that values, and this is constant value, so you have the radius and you have the acceleration due to gravity. So then you try to get the value of allowable speed. So then that will be definitely less than the design speed, small v. So that you have to provide at that particular location, mentioning that the allowable speed is only this much due to the constraint of maximum super elevation and maximum lateral coefficient of friction. So there is a small numerical over here. So the radius of the horizontal curve is 100 meters. So therefore R is equal to 100 meters given data, and V is equal to, as it is in kmph, so I am writing it as capital V, 50 kmph, and the design lateral coefficient of friction FL is equal to 0.15. That is what the given data. So first thing what they are asking is calculate the super elevation required if full lateral coefficient of friction is assumed to develop. So you have to calculate the super elevation taking that lateral coefficient of friction, that is nothing but FL is being contributed fully. So therefore you know the formula E plus F is equal to, E plus FL is equal to V square by GR. I am not taking the 75% of the speed because I am not going to design the super elevation here, because I was just asked to calculate the super elevation. So when you are asked to calculate, you don't think about the design and you don't try to reduce the speed. You are only advised to take the reduced speed at the 75% speed when you are asked to design the super elevation. Until unless you don't see the term design, so you need not to think about the 75% of the speed. So therefore E plus FL is equal to V square by GR. V is nothing but small v is equal to 50 divided by 3.6, which will be somewhere around 13.88 meters per second. So therefore E is E plus FL. So already he is telling that FL is being given. You have to assume that it has been fully developed. So therefore given fully value is nothing but 0.15 is equal to 13.88 meters whole square divided by G is nothing but 9.81 multiplied by R is nothing but 100 meters. You are going to get the value of 0.047. So if you multiply that in 100, so that is nothing but 4.7%. We don't bother about the percentage value because we are not going to design how much ever is they are getting. So that is what you have to mention over here. So this you can express already, the slopes can be expressed as 1 in n or small n. So this is your small n percentage. Similarly, you can express this as 1 in n. So that will be, if you convert that, it will be somewhere around 1 in 21.2. So therefore, it means nothing but if you travel for a horizontal distance of 21.2 meters, you're going to have a rise of 1 meter. So that is how you provide the superelevation. It means nothing but, so there is a road like this, you are providing the superelevation. After 21.2 meters, you're going to have this superelevation. This is the central portion of the circular curve. The central portion of the circular curve is going to have this fixed superelevation that you are attaining in a length of 21.2 meters. The second question is, calculate the coefficient of friction assuming needed if no superelevation is provided. So he's telling that if no superelevation is provided, so if you are providing superelevation as 0, so that it means nothing but E is equal to 0. So this is the second question. So E is equal to 0. So it means nothing but you have to take only design for FL, lateral coefficient of friction. Okay. So FL is equal to V square by GR. Only thing is what has been given in the question is if no superelevation is being provided. So the amount of completely centrifugal force has to be balanced by only lateral coefficient of friction. Therefore 13.88 whole square divided by GR. So you'll get somewhere around 0.19. So the third condition is calculate the equilibrium superelevation if the pressure on the inner wheel and the outer wheel is equal. So equilibrium superelevation is nothing but E equilibrium is nothing but when you take FL is equal to 0 in this condition. When you take FL is equal to 0, okay, so then that condition is nothing but equilibrium superelevation. Again, this also will be equivalent to V square by GR. So therefore E equilibrium plus FL is equal to 0. As FL is 0, so equilibrium is equal to V square by GR. As we are having the same values on the right side, so this will be 0.19. So here it is 19% over here. So this is superelevation 19%, but this is not a percentage superelevation here because this is only lateral coefficient of friction. So this is nothing but 19% means 1 in 5.1. So this, because this is a superelevation, so in 5.1 meters itself, you are going to have a rise of 1 meter. Okay. So this is superelevation 19%, 1.19%, and this is lateral coefficient of friction 0.19. Next one, here there is a question on the design superelevation. So the design superelevation for a horizontal highway curve of radius 500 meters and its speed 100 kmph. So we are going to design the superelevation in 4 steps. If you can recall that steps, the first one is nothing but calculate the E design, step 1. So I am writing here step 1. E design is equal to, I have to take the 0.75% speed. So that is nothing but 0.75 V whole square divided by GR. So I know that V is equal to 100 kmph. I convert that into kilometers per second. 100 divided by 3.6, which is nothing but 27.77 meters per second. 3.6. So therefore this is meters per second. So therefore you substitute the value of this 0.75 V 27.77 whole square divided by GR, and you substitute the value of G is equal to 9.81 and multiplied by 100. Then you are going to get the value of superelevation as 8.8%. So that is nothing but 0.088. So if you multiply that, it is nothing but 8.8%. So does the problem end over here? No. Why? Because your E design is greater than, of course, terrain is not mentioned over here. You take this as plain terrain. Okay. So this is greater than 7%, which is nothing but the maximum superelevation which is allowed for plain terrain. So now you restrict the value of this design superelevation to E max. So therefore the second step is equal to E maximum plus FL. E maximum plus FL is equal to, here again you need not to take the value of design speed, 75% speed. You have to take the design speed, which is nothing but V square by GR. So again V is nothing but 27.77 whole square divided by 9.81 into 500 the radius. So therefore you are going to get the value of FL, which is nothing but FL is nothing but 0.087. That is what the second step. So this value, if you check the value of FL, which is nothing but 0.087, is less than 0.15. So your problem is safe over here. So you have designed the superelevation with a maximum superelevation, so of 7%. You have restricted that to 7% over here. So this is 0.07 plus FL is nothing but 0.087. So that is what your problem has ended over here, the second step itself. Okay. So this is the third problem on the design of superelevation. I've changed the previous problem. The value of the radius as 300 meters and speed as 100 kmph. So I'll go with the step 1. So that is nothing but E design is equal to 0.75 V whole square divided by GR, where R is equal to change it to 300 meters. So therefore your value of E design is equal to 14.7. So 0.147, that is nothing but 14.7, which is very high when compared to that of E maximum, which is nothing but 7%. Now the second step is nothing but you have to restrict the value of E design to E maximum, which is nothing but 0.7, 7%, plus FL is nothing but you have to calculate the FL value. So therefore FL is equal to V square by GR, you have to take the design speed. So therefore 27.77 whole square divided by G into R 300 meters. So the lateral coefficient of friction, you will arrive some value as 0.19. The second step also FL is greater than 0.15. So here basically while calculating the design super elevation, it has exceeded the 7%. So then we have to take the limited value of 7%. And I checked the value of FL, and this FL value has also turned out to be higher than 0.15. So therefore you have to go for reducing the speed of the section. So by taking the higher maximum values of sublevation, that is nothing but E maximum, plus FL is nothing but your maximum value of lateral coefficient of friction 0.15, which is nothing but 0.22 in this case, is equal to VA square. So here unknown over here is nothing but VA, allowable speed, divided by G is nothing but 9.81 into radius is equal to 300 meters. So then you can get the value of allowable speed, which is nothing but 91.6 kmph. So directly I have converted this into kmph. Initially you will get this as VA is equal to 25.44 meters per second, but initially this your original speed is 27.77 meters per second, but whereas this has been reduced to 25.44 meters per second, which is nothing but 91.6 kmph. So this is what the problem which has been involved in calculating in for the steps, because we have crossed the value of maximum super elevation, so we also crossed the value of lateral coefficient of friction, so because of which we have tried to reduce the speed by giving some particular value of allowable speed. So I sincerely acknowledge the use of publicly available images and that supported and enhanced the visual clarity of this presentation. Thank you. I conclude the session over here.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.